The first thing on the list here in our 9.4 notes, which we are on the back of page 61, the first thing talks about two kinds of sequences, arithmetic and geometric sequences. All right, so I'm going to go ahead and just give you an example of each and see if you can figure out what's different about them and what makes them arithmetic. I'll give you a couple examples of each. So an example of an arithmetic sequence would be 2, 6, 10, 14. That's one example. And another example would be 8, 3, -2, -7, ... Those are examples of arithmetic sequences. So can anybody tell me what you notice about those two sequences?
+5 -5. Or +4 -5.
Okay, so the top one I am getting from term to term by adding 4. And the bottom one I am getting from term to term by adding -5. That's called subtraction when you add a negative. So arithmetic sequences are sequences where you get from term to term by adding the same number. Okay, so in the top one we were adding 4, and in the bottom one we were adding -5. Now a little bit of vocabulary for you. The number that you add, that same number, is called the common difference. So if I gave you this sequence and I said, what is the common difference? You would tell me 4, because that's the number that I am adding. If I said, what's the common difference here? You would say -5, because that's the number that I'm adding. Everybody still with me? So when someone asks you, like we are in the very next section here, is this arithmetic? You're going to look at all the terms and you're going to ask yourself, am I adding the same number? If you are adding the same number, it is arithmetic. All right? Now we're going to come back and talk a little bit more about that in a minute, but let's get the other kind covered. Here's a couple of examples of geometric sequences. Those are geometric sequences. Now, what do you notice about them?
Are you multiplying?
I am. In this one, I am multiplying by 3. And in this one, I am multiplying by 1/2. Now, some of you might say, oh, you're dividing by 2. But with sequences, we either add or multiply. So instead of saying dividing by 2, I'm going to say I'm multiplying by 1/2. A geometric sequence is a sequence in which you get from term to term by multiplying by the same number. And that same number is called the common ratio. So with arithmetic sequences, we have a common difference, and with that's the number we add, and with geometric sequences, we have a common ratio, and that's the number we multiply by. All right. Now, do you have any room left up here in this section of your notes? Because I have one more thing to add. The formula for arithmetic sequences, I'll do it in a different color. The formula for arithmetic sequences is this. And the formula for geometric sequences is this. Now, the first thing I want you to do, don't start freaking out, just write those down. These got to be in your notes. You got to have these written down. This is the formula for arithmetic, and this is the formula for geometric. And I will explain what all that means.
Is that like A comma R?
That's A sub 1, just like this is A sub 1. Those are ones.
Okay. Okay.
All right, so make sure you have those written down. Make sure you have those written down correctly. This is a subscript, so it's underneath. So it's A sub n, A sub 1, A sub n, A sub 1. That is an exponent, so it's r raised to this power. Now, let me show you, and I know you're probably out of room there, so you don't even need to write this down as long as you kind of can follow what I'm talking about. If I look at my first sequence right here, and I said, what, if I got the first term, second term, third term, fourth term, suppose I wanted the 10th term. I could keep adding 4, right? I certainly could do that. But the formula will give me the 10th term. Okay? Here's how it works. If I want the 10th term of this sequence, I would say A sub 10. That stands for 10th term. If this stands for 10th term, what does this stand for? First term, which is 2. D is your common difference, and what did you say your common difference was? 4. And if n is 10, if you said A sub 10, n is 10, then 10 minus 1 would be 9. And the 10th term of that sequence, if you kept adding 4 over and over and over again, the 10th term of that sequence would be 38. That's how that formula works. So for this one, it works the same way. If I wanted the 10th term of this one, A sub 10, I'm randomly making that up. You could find the 5th term or the 19th term, any term you wanted. The 10th term in this one would be the first term, which is 2, times the ratio, which you said we're multiplying by 3 to the 9th power. So I'll need a calculator to do that. 2 times 3 to the 9th. So that would be 39366. Wow, that's a big number. So that's how those formulas work. Does anybody have a question about where I was finding the 10th term of this sequence, where these numbers came from? I plugged into this formula, and for this one, I plugged into this formula. Anybody have a question about where any of those numbers came from? Okay. There he is. Okay. All right, let's move on then in our notes. Here we go. Whoop, yeah. Identify the following as arithmetic, geometric, or neither. Now, it is definitely possible to be neither, because remember, the only way you can be arithmetic is if you add the same number over and over. The only way you can be geometric is if you subtract the same number over and over. So let's look at this first one and decide which one it is. What do you think? What's happening?
It's geometric, right?
Why?
Because you're dividing by 2 every time.
So in other words, our ratio is 1/2. We are multiplying by 1/2. So you are right. It is geometric, and the ratio is 1/2. We multiply by 1/2, by 1/2, by 1/2, by 1/2. Very, very good. What about the next one?
Arithmetic.
When we say the word as a noun, it is arithmetic. When we say it as an adjective, it's arithmetic. So this is definitely arithmetic. And what's our common difference? What is the number that we are adding?
10.
Yep, perfect. How about this one? What'd you say? She says arithmetic. And what's your common difference, Katie? If it's arithmetic, what am I doing? I'm adding 8. The common difference is 8. I'm adding 8.
Neither.
Good. Now, can you see that there is kind of a pattern here? To get from here to here, we added 2, and then we added 4, and then we added 6. So we would probably add 8 if we were going to keep going. But because we are adding a different number every time, it's not arithmetic. So this is neither. Very, very good. How about E? Geometric. And what's our ratio? 2. How about F?
Arithmetic.
Yep, and the ratio is?
Add 2.
Yep. Or no, I said ratio, I meant differences. The difference is 2, not ratio, the difference is 2. You add 2, good. And the last one.
Neither.
Neither. Does anybody see the pattern here? Though it's definitely neither. It is not arithmetic and it is not geometric. But does anybody recognize these numbers? Is there anything special about those numbers? Forget how you get from one to the other. What's special about 1 and 4 and 9 and 16 and 25?
They're prime. Or like they're squared.
They're squares. They're squares. So this is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So if you were going to continue the sequence, the next number would be 36, and then 49, and so on and so on. So this is not arithmetic or geometric, but it's a very important set of numbers, for sure. All right. So everybody's clear on arithmetic and geometric, right? All right. Okay. Let's look at the next set of problems, which is a little bit different, but very, very easy. B sub n is simply a way of expressing a sequence. So it says find B sub 1. Now look, This is your formula that you're starting with. It's a random formula. Either I made it up or got it out of a book or something. There's nothing special about it. It's a random formula. But B sub 1, so I'm letting n be 1. What do you think B sub 1 would be using this formula?
6.
6. Perfect. It's 6 over 1. So what would B sub 2 be?
3.
3, because you're putting a 2 here. 6 over 2, right? It'd be 6. It'd be 6 over 2, which is 3. What's B sub 3?
2.
Yep, 6 over 3, which is 2. And what's B sub 4? 3/2. 6 over 4, or 3/2. Now it says, find the 70th term. Well, that's a big number, but is that any harder than what we've been doing? No. The 70th term would be 6 over 70, which reduces to something. 3 over 35? That's easy. Let's try the next one. Same thing. Another completely random formula, and you're going to find some terms of the sequence. So C sub n is 2n plus 1. This letter means nothing. It's just this sequence is named C instead of B or A. But we want to find C sub 1, 2, 3, 4, and 70. Okay, can you do that? What's C sub 1?
3.
Yep. If you're out there in La La Land, folks, it's 2 times 1 plus 1. You're letting n be 1. So you're putting in 1. So 2 times 1 plus 1, 3. All right, what's C sub 2? Now put in 2. So that would be 5. C sub 3, put in 3.
11.
9.
141. If you have a formula, isn't it easy? You just plug in what you need.
Easy is a banned word.
Okay, number 3. Now, this is where it's going to get a little more interesting because I didn't give you a formula. All right? So we're going to have to figure this out. So let's look at 3a. So the first thing I want you to do, that you don't even have to figure it out. It tells you it's arithmetic. Would you agree that's arithmetic? What's the common difference? How am I getting...
Wait, how did you get 4 for the last one and the other one?
It's 141.
Oh, sorry, I thought it was, I couldn't tell that those were ones. I thought you were setting it up like brackets, so it kind of looked like...
No, it's 141. Because I put in 70. Now, how are we getting from term to term here? What's our common difference? Negative 4.
Negative 4.
Negative 4. I'm subtracting 4. That's the common difference. Now, look back at your notes. What is the formula for an arithmetic sequence? I had you write it down. This is what you should have written down for an arithmetic sequence. Is that what you wrote down? Mm-hmm. So the nth term is the first term. Okay, what's our first term in this sequence? 3. Plus the common difference, which you have already figured out is negative 4 times n minus 1. So when you build your own formula, kids, you're going to put in your own first term, and you're going to put in your own common difference, whatever it is for your sequence that you are looking at. Now, if I clean this up a little bit, it says 3 minus 4n plus 4. Please don't get lost in the arithmetic. This is a negative 4n and a positive 4. And then I have like terms, so I'm going to say 7 minus 4n. And there's the formula that you are going to use. So where it says find an explicit rule, that's just a fancy way of saying formula, okay? So a sub n is right there. We started with the one that works for all arithmetics. We plugged in our first term and our common difference, and then we just did some arithmetic to clean it up. So now when it says find a sub 8, what am I going to do? I have my formula now. How do I find a sub 8? Plug in 8.
You do.
So 7 minus 4 times 8? So that'll be 7 minus 32, which you can use a calculator if you want. What is that, negative 25? You'll have a calculator for all this too, because there's a lot of arithmetic with this. All right, did everybody follow that? Because we have another example to do now that's going to be exactly the same way. All right, let's try it. Here we go. They tell me the thing is arithmetic. Normally I would have to figure that out on my own, but you can tell it's arithmetic because what's the common difference? What's happening here?
Minus 0.5.
Yep, we're subtracting a half. So our difference is negative 1/2. The decimals don't bother me. I'm subtracting 1/2. Okay? So it's arithmetic. My formula is this. For all arithmetics, any arithmetic sequence. Remember, we plug in our first term and we plug in our d. So my formula will look like 10 minus 0.5 times n minus 1. I could say plus a negative, but I'd rather just say minus.
Miss Ford, will we have to remember these? Like the formulas?
Well, there's only 2 so far, so yeah.
Okay.
Okay? And really, Ari, as we do more of these, more practice, you're just going to get automatic with that because it's the same one over and over and over again. All right, so once everybody got the 10 and the negative 0.5 plugged in, so now I'm going to do my arithmetic. So 10 minus 0.5n plus 0.5. I'm going to distribute that d value. So my formula is going to be 10.5 minus 0.5n. 10 plus 0.5, that's 10.5, and then minus 0.5n. So what's the 8th term going to be? It's asking me for the 8th term again. So the 8th term will be 10.5 minus 0.5 times 8. So use your calculator if you need to. Did you get 6.5? I hope. Is that okay? Yep, I see a thumbs up there from Ella, thank you. All right, so we've done 2 of these. There's one more, and I would like you to see how far you can get on your own. So with this third sequence, C, problem C, see if you can figure out the common difference. That should be easy. see if you can figure out your formula, and then find the 8th term. All right, so let's take a couple minutes. Find your common difference, and then write your formula. Then we'll plug 8 into our formula and have our 8th term. Isaac, what's my common difference?
I don't know.
Isaac, I want your beady little eyes on that screen every moment from now on. You got it?
Yep.
Can somebody help Isaac out? What's the common difference in this problem?
6.
6. Isaac, the common difference is the number that we add over and over again to build this sequence. Now, you have to write your formula, and you're going to put in your first term and your difference. So I'm going to put in 10 and 6. Do the arithmetic. How many of you got 4 plus 6n as your formula? Did anybody get 4 plus 6n for your formula?
I did.
Mary Kate's raising her
I did
hand.
too.
Good, super. Anybody who didn't get that, look at this and tell me what question you have about it. My first term is 10. My common difference is 6. I did the distributive, and I collected like terms. You might have 6n plus 4. That's the same thing. So now, how will I find the 8th term? Plug in 8. So is that going to be 52? Does anybody have a question about that? Okay. Now, here we go to the next one, which is number 4. It says, given, they don't give you the whole sequence. Given these terms, find the first term and the 100th term. So let's make sure you understand what's going on here. You have been given, it's an arithmetic sequence, but you've been given the 4th term is 13 and the 7th term is 22. So in other words, if I drew it out, there's the first term, 2nd term, 3rd term, 4th term, 5th, 6th, 7th.
Would you subtract those?
Oh, well, let's talk about that for a minute. So, first of all, hang on to that thought real quick. Does everybody understand the picture I drew here? That this is what's being described in the problem. I am trying to find this number back here and the 100th number in the list if I just kept going. Sometimes there are little tricky things you can do with these problems, but I am going to show you the way that will always work. Okay? I'm going to show you the way that will always work. If I just consider the part of the sequence that I know about, so I'm only going to look at the purple part. If I only look at the purple part, then this is the first term, because that's the first part of the purple, that's all I'm looking at. and this is the fourth term. Would everybody agree with that? If I only look at the part of the sequence that's in the purple. So from the first number I knew to the last number I knew. Now my formula for all arithmetic problems, every arithmetic sequence problem, that's the formula I'm going to go to. My formula says that the fourth term, I put a 4 here, which means I gotta have a 4 here, is the first term plus d times 4 minus 1. But I know that the fourth term is 22. I know that the first term is 13, and 4 minus 1 is 3. Can I solve that? Am I blowing your mind, Daz? I think I can solve that. I'll subtract 13. So it looks like d is 3. So the formula says the last term equals the first term plus the common difference times n minus 1. Well, my last term was the fourth term, so n was 4. 22 equals 13, first term, plus d times 3, 4 minus 1. So I just subtract 13 and divide by 3, so it looks like my difference is 3. Which means this number would be 16, and this would be 19, and that's 22, and this would be 10, and 7, and 4, going backwards. Now, these problems, depending on how they're set up and which terms you know, can be done with, like I said, some trickiness or some like one-off things. This way will always, always work. So now I know my common difference and I know my first term. The only thing left to find is the 100th term. So use the same formula. What will the 100th term equal? The first term, which is 4, because now I'm doing the whole sequence. So the first term is 4, the common difference is still 3, and n minus 1 is 99. Remember in the formula, that's an n minus 1. So if you put 100 here, then this is going to be 99. So the 100th term is 301.
Is that it for today?
What? Was that some kind of joke?
That was a dumb question, William. Come on.
All right, so here we go. We're ready for the next one. We're going to do another one just like that. We're going to try to be really systematic about it. All right, so this time we know the third term is 8, so I'm just going to go ahead and draw a picture of it. The third term is 8, fourth, fifth, sixth, and the seventh term is 36. So let's look at what we know. So I'm forgetting about everything outside of the brackets. This is my sequence that I'm looking at. So this is my first term. second, third, fourth, and this would be my fifth term then. First, second, third, fourth, fifth. My formula that I use for every arithmetic sequence problem says if I'm going to let my last term, my nth term, be 5, if I'm going to put a 5 in here, then I have to put a 5 in here. The fifth term is 36. My first term is 8. I have no idea what my difference is, but I know that's 4. So if I subtract 8 and divide, it looks like my difference is 7. Now I'm going to stop right there. Does anybody have a question about what I've done so far? Any question about this so far? Because we're not done with the problem yet. I want to make sure you're all keeping up. Now, okay, if we know that our difference is 7, then we can fill in all these blanks. Because remember, this is the number that you add. So 8 plus 7, plus 7, plus 7, plus 7. If you want to go the other way, if I want to go backwards, going this way, I'm adding 7. So going that way, I will be subtracting 7. So this will be a 1, and this will be a -6. Does that part make sense to everybody? So now we can look at the whole sequence. Now that we've filled in all the blanks, we can look at the whole sequence. And now we have to find the 100th term. So remember your formula that you use with every single arithmetic sequence problem. If you want the 100th term, if you're going to let n be 100, then you're going to have -6, which is your first term, plus 7, which is your difference, times 99. 100 minus 1. And that is 687. Okay, any question about that? We got one more to do. So hopefully you're starting to get the hang of it. I know it's last period, guys, but we really got to stay focused. All right, so here we go. So there's the first, second, third, fourth, fifth, sixth, 7th, 8th, 9th. Okay, so here's my sequence. They gave me the 6th term, and there's the 7th, 8th, 9th term. And I got to fill in all of the blanks. And find the 100th. So let's block off what we're going to look at to start. If we block off just that part, this is our first term, and this would be second, third, fourth. So in our formula that we use for every single arithmetic sequence, so see, already we're using it so much you probably have it memorized already. The 4th term, you're going to let n be 4. because that's your last term. And if n is 4, then this n is 4. So negative 10 equals negative 1 plus d times 3. Negative 10 is your fourth term of your bracketed sequence. Negative 1 is the first term of your bracketed sequence. So I'll add 1 and divide. I got negative 3. Now, what does that tell me? When I say D is negative 3, what does that mean? That's how I'm getting from here to here to here to here. I'm adding negative 3. So this would be negative 4 and negative 7 and negative 10. So if I'm adding negative 3 here, won't I have to do positive 3 going back this way? So this will be 2, 5, 8, 11, 14. So negative this way, because D is negative 3. So that's forward in the sequence. So backwards is the opposite. Okay? Now with the 100th term. So I'm going to use my same formula.
Would you do 14 minus 3 times 100 minus 1?
Exactly. I'm just going to put 99, but it would be 100 minus 1. That's exactly right. That is perfect. That's absolutely perfect. Because your first term is 14, you're looking at the whole sequence now. So your first term is 14. Your common difference is negative 3, so you put minus 3. You could say plus a negative if you want, and then n minus 1 is 19. Absolutely wonderful. Perfectly done. I got negative 283. Just typing it in on my calculator. Okay, now we're going to do the same exact thing with geometric sequences. Now, what is going to be different? One thing only. Does anybody have any thoughts on what will be different? The directions are the same. Well, they want the 10th term now instead of the 100th. But other than that, what will be different about the way? Exactly. The formula I use will be different. Look back at where I had you write this down. Every one of these problems, we will be using the formula a sub n equals a sub 1 r to the n minus first. All right, let's get through one example, and then I'm going to tell you a little story. Okay, I haven't told you a story in a while, so I'm going to tell you a story, but let's see if we can get through one example. So here we go. Oh no, these are easy. That's all right, I'll tell you the story anyway. Let's do one first, and then these are easy. So this is our geometric sequence. Would everybody agree it's geometric? What's my ratio? How am I getting from term to term? Multiplying by 2. Yep, multiplying by 2. Times 2. Remember, if it's geometric, we're multiplying. So times 2. Well, the first term is 3. That's given, right? That's not hard. How about the 10th term? What is the 10th term going to look like? Look at your formula. So the 10th term will be 3. That's your first term. Times your ratio, which is 2. to the n minus 1. Now, if you're doing a sub 10, then n minus 1 would be 9. Kids, I think that's easy. Is everybody following along with that? So now I'm going to type this in on my calculator. 3 times 2 raised to the 9th. And you should get 1,536. All right, I thought this was going to be one of the harder ones. That's pretty easy. Would you agree? Listen to my story now. You ready? Back in the day, long time ago, I had, well, not that long ago, back in the 80s, I had Isaac Michael, your classmate. I had his mom in class. Great student, very smart. Had her in Algebra 2. And one day she came in to the classroom and said, Mrs. Ford, my dad and I were watching TV last night, and they said something that can't possibly be true, and we were hoping that maybe you could help us figure this out. And I said, okay, what is it? And she said, well, they said on TV, I don't know what program they were watching, but something on TV, they said that if you took a standard checkerboard, you know how you play checkers? If you took a checkerboard and put 1 checker on the first square, 2 on the next one, 4 on the next one, 8 on the next one, 16, 32, and so on. So we're stacking checkers, this many checkers on each square. By the time you got to the last square of the checkerboard, you would have enough checkers to reach the nearest star. And I remember like it was yesterday, she said, Mrs. Ford, the nearest star is the sun, and it's 93 million miles away. That can't possibly be true. Well, why am I telling this story today? What kind of a sequence is that? Geometric. And I have a formula for geometric, don't I? My formula for geometric is this. Does anybody happen to know how many squares there are on a checkerboard?
Isn't it like 10?
No.
No, like a cross.
Oh, no, it's 8 by 8, so there's 64. Yeah, so you're close, you're close. And there may be checkerboards that have 10, I don't know, I'm familiar with 8. So I'm going to go with 8. 10 would be even worse, even bigger, so I'm just going to go with 8. So checkerboard has 8, so 64 squares on the checkerboard. So I wonder if this is how many checkers there are on the first square, second square, third square, fourth square. I wonder if we can figure out how many there would be on the 64th square. I think we can figure that out. Our first term is 1. What's our ratio? What am I multiplying by? 2. And if that's 64, my exponent will be 63. Does that make sense to everybody? It's pretty simple. So let's type it in on our calculator. 1 times 2 to the 63rd. Now that's 9.22 times 10 to the 18th. All right, now guys, that's how many checkers I have. That's not miles or anything like that. That's how many checkers are piled on the 64th square. Wow, that's a lot. I think checkers, an inch of checkers might be maybe 3 checkers. So I'm going to divide that number by 3. And now I have 3.07 times 10 to the 18th inches. That's a lot of inches, guys. So I'm going to divide that by 12. So I have 2.56 times 10 to the 17th feet. And then I'll divide it by 5,280. And I have 4.85 times 10 to the 13th miles. Guys, the sun is 9.3 times 10 to the 7th miles away. This is way more far away than the sun is. Isn't that absolutely amazing? Guys, isn't that amazing? That's incredible.
That's crazy.
That's crazy. I mean, you think, how can that possibly be? But on this little, I know, on this little checkerboard, we've got 10 to the 13th miles of checkers. That number has a ton of zeros. It's a huge, huge number. That's remarkable. Just absolutely remarkable. All right, we got time for one more. So let's get one more done, and then we might have time for two more. Let's get two more done, and then we'll be done for the day. We'll finish this page. So these are easy. They don't take long. Here we go. What's the ratio for problem B? What is happening? What's my ratio? I'm dividing by 8, which is multiplying by 1/8. Chase and Caroline, not sure what's going on. And Isaac, I still don't see your face. The first term is 8. There's no mystery there. It's 8. That's the first term. That means first term. And so the 10th term, here's my formula. So if I put in a 10, it's going to be 8 times 1/8 to the 9th. And you can type that in easily on your calculator. Just make sure that you put the 1/8 in parentheses. So 8 times 1 divided by 8, close the parentheses, and raise it to the 9th power. You should get 5.96 times 10 to the -8. Remember, you've got to pay attention in this whole chapter, the first part and this last part. You're going to get scientific notation a lot. This is a little tiny number. If you forget to write the E part, if you just write 5.96, you're going to miss it. You have to pay attention to the E at the end, which tells you it's scientific notation. All right, is that okay with everybody? You type that in, get the correct answer, hopefully. All right, one more. Ella, what's my common ratio here? What am I multiplying by?
Would you multiply by the -6?
Well, if I multiply by -6, this would be a 36. What do I multiply by to get from here to here?
Oh, I see, a 3.
Well, it's -3.
-3.
Yep, I'm multiplying by -3. -6 times -3 is 18. 18 times -3 is -54, and so on. My first term is -6. You don't have to figure that out in these problems. It's right there. And then we want the 10th term. That we have to figure out, but we have a formula for it. The 10th term, putting 10 in for n, the 10th term will be the first term times my ratio to the 10 minus 1, or 9th power. So this one types in just as easily, -6, parentheses, -3, close parentheses, to the 9th. And I got 118,098. Anybody else get that?
I did.
Awesome. Awesome. All right, we're going to stop there for the day. You guys got to stay on for the blessing. Please do not leave the screen, or I will have to mark you unverified. Chase, I'm not sure, I still don't see you. So I'm gonna have to mark you absent today. Chase, why are you always turning your camera off and walking around?
I just got up because you said the lesson was over.
No, no, no. The lesson is over, but class isn't over. Cammy,
So I can't turn my camera.
Cammy, whole tree never showed up, right? All right, everybody stays on for the blessing. As soon as Mr. Bridges or whoever talks is done, you're free to go. But not until.